solving polynomials, right? So here we're going to list all possible rational zeros from our rational zero theorem. We're going to use synthetic division to find an actual zero using our factor theorem, remainder theorem together. And then we're going to use the remaining quotient to find the remaining zeros, and depending on what power that is, depends on how we may have to do that one. All right. So here, f of x equals x to the third minus 2x squared minus 11x plus 12. All right. So we want to find all the zeros. We want to set it equal to 0. The difference here is we're not given one of our zeros like when we talked about the factor theorem or anything like that. So we don't know any of those. We have to use our possible rational zeros to find a place to start. So I'm going to do this part in red here. List all possible rational zeros. So remember, my a sub n is the thing times the biggest power, and my a sub 0 is the constant term. So, and if you recall, a sub 0 and a sub n, I said, let's find the absolute value is what I do, all right? Because I put the plus or minus in my possible rational zero list. So a sub 0 is 12, and then 1, right? This is understood 1 there. So those are my a sub 0 and a sub n, and their absolute value doesn't matter. They're both positive, but I'm still disregarding the sign. That's why I put the absolute value. So when I talk about this, I'm going to find my factors of 12, 1 and 12, 2 and 6, 3 and 4. My factors of 1 are just 1. So I'm going to have plus or minus the factors of 12, 1, 2, 3, 4, 6, and 12. So I like to go down this side and back up this side, right, just to put them in order. I'm OCD, I guess, that way. All right, and then over 1. So then here we have plus or minus. We have 1 over 1 is 1, 2 over 1, 3 over 1, right? When it's just 1, it's just all the numbers in the numerator or the top, right? You divide anything by 1, you get that number. So those are my possible zeros. Recall now, I only have 6 numbers listed here, but recall that's 12 possibilities, okay? That's 12 possibilities. So when you're solving these, I'm going to find at most the biggest power here, which is 3. So if we want to talk about expected value, if I expect to find 3 out of 12, right? If I can find at most 3 out of 12, I would expect to find 3 out of 12, 1 out of every 4. Okay? So if I'm trying to find one of them, well, if it takes me 1 out of every 4 tries, maybe I have to try 4 times before I find one, but maybe I get lucky. Is there any magic to what you start with and what you end with? No. I am always going to start with 1 and then negative 1. And then the next number in my list, 2, and then negative 2 and 3, and so on and so forth. If I have fractions, I am not going to do a fraction in synthetic division unless I have exhausted all of my integers and whole numbers with the plus or minus integers, okay? Until I have exhausted all of those, I'm not going to try a fraction. You go right ahead and you know, try a fraction with your bad self, because that's fine. I'm just not going to do it, all right, unless I have to. So here, the next thing it asks us to do is to use synthetic division to find an actual zero, okay? Now, this is where it is nothing more than trial and error. That's what I just talked about. How do you know which one to start with? I don't. I'm just going to start with 1. May or may not work. So here, I'm going to put 1 on my porch, and then I'm going to put 1, negative 2, negative 11, and 12. Okay, and that's what, 1, negative 2, negative 11, and 12. Those are my numbers I'm putting in there, the coefficients, right? They're already in order, descending order, and there's none missing. So drop down the 1. 1 times 1 is 1, and then we add. That's negative 1. 1 times negative 1, negative 1. Add them together is negative 12. 1 times negative 12. Look at that. We got lucky. We didn't have to try it 4 times. We got it on the first try. That's just luck. I don't try 1 first because I knew it was going to work. It just happened to work here, okay? So we have then, if we come over here, we already know that x minus 1 times something equals 0, right? If I'm solving this. Because if 1 works, then it's x and the different sign, right? X minus 1 is a factor. If I have my box down here, like if I had this, maybe I should have an answer box down here. So, okay, we're trying to fill in my answers here. Well, if I was trying to do that, then I already know that 1 works because I'm trying to take this away. I already know 1 works because 1 gave me a remainder of 0, right? Oh, I did move it and it didn't move back. Hang on. Should be somewhere about right there, I guess. Yeah, that's pretty close. All right. Sorry, it moved around on me. All right, so x minus 1, and what's left? Well, remember, this is what goes here, right? So then that's going to be x squared. That's what this is, and this is minus x, right? So this is minus x and then minus 12. And now that factor's much simpler than all this other business because that's just a list method. We want factors of 12, right? List method, 3 terms. There's a 1 in the front. It's list method if it works. So we have 1 and 12, 2 and 6, 3 and 4. Factors of 12 that subtract to give me 1. Don't worry about the negative sign, okay? So the ones that subtract to give me 1 are going to be 3 and 4, right? So put a 3 and a 4. This says the bigger number gets this sign, okay? They're different, right? The only way to get a negative 12 is to have different signs there, positive times negative. So, or negative times positive. So here, negative, that says different, that says bigger number, so bigger number gets a negative. Which one of these is bigger? That gets the negative, okay? And then since they're different, the 3 gets a positive, and now we have the whole thing factored, and I can set each one of those factors equal to 0 and solve it. Right, this one we already have, right? We know that 1 is an answer. That one I already have down there. Let's go ahead and just add some color here. X equals negative 3. And then here add 4. Oops. I combined some pen strokes there. X equals 4. So then negative 3 and 4. So 1, comma, negative 3, comma, 4 in whatever order. And if you started, look, if you didn't start with 1, if you started at 12, or if you just said, let me pick 4 and try 4, and you found 4 first, then your polynomial that you're factoring with list method looks different than mine. That's okay, as long as you get all 3 answers. This is not the only way to do this. There's many, many ways that are correct to work a problem like this. So, and use the remaining zeros. I guess I could underline that. I kind of did that kind of in a combination of brown and green there, okay? So let's look at another one of these. 3x cubed minus 7x squared minus 2x plus 8. So again, I want to solve this the same way. I want to find the possible zeros. Then I want to use synthetic division to find one. And then if I'm in an x squared at that place, then I'm ready to factor it and see if I can go further. Or you may even have to use quadratic formula or complete the square some other way. Okay? Once you get it down to x squared, it doesn't force the fact that it's going to factor. It may be any of the ways you learned or have ever seen in your past on how to solve something with x squared, okay? Because that's the way math works. Once you know something in math, it is now a building block that can be used at any point in your math life from that point forward. So we're going to set this equal to 0, and this is my a sub n, and this is my a sub 0. And again, for my absolute a sub 0, I have 8. That doesn't look like a very good A, but anyway. And then for my absolute a sub n, remember I'm not worried about the signs here. I have 3. So my factors of 8 are 1 and 8 and 2 and 4. My factors of 3 are 1 and 3. So remember it's plus or minus the factors of 8, and I like to list them out from smallest to biggest, but there's no magic to that either. Okay? I know a lot of y'all think algebra is nothing but magic, all right? But it's okay. It's real math, all right? And so then plus or minus 1 over 1. So I'm going to take all 4 of these over 1 and then over 3. Okay? So 1 over 1 is 1, right? 2 over 1, 4 over 1, 8 over 1. Those are the boring ones, right? Over 1 is always the number. Then we take 1 over 3, 2 over 3, 4 over 3, and we simplify these as we go, by the way. But none of those simplify. 1/3, 2/3, 4/3, 8/3. So what I was saying earlier is I'm going to try all 8 of these possibilities. So there's only 4 numbers there. Don't forget it's 1 and negative 1, 2 and negative 2, 4, right? So there's 8. I'm going to try all 8 of those integers before I move on to 1/3 or 2/3 or 4/3 or 8/3. If you want to do that, by all means, have at it. I ain't doing it, all right? So these are my possible zeros. So now I'm going to take this thing and say, okay, let me use synthetic division to find one. So I'm just going to start with 1. I'm going to hope 1 works. If 1 doesn't work, I'll go to something else. 3, negative 7, negative 2, and 8. So drop the 3 down. 1 times 3 is 3, and then we add. It means don't change the sign of the 3. Negative 7 and 3 is negative 4. 1 times negative 4 is negative 4. Add those together. Negative 2 and negative 4 is negative 6. 1 times negative 6 is negative 6, and that's 2. Since that thing is not 0, that's not 0, then guess what? That didn't work, okay? When that remainder is not 0, this does not work. So I'm not going to erase it here if you wanted to erase it or whatever, and you might even want to do your synthetic division smaller than that, because if I do it that big, look at all the ones I have to check. I have 15 I could check, and I expect to find how many? 3, which means now I expect to have to try it 5 times before I find one of them, okay? So let's go to the next one, which the next one I'm going to do is negative 1. I'm going to write a little smaller here, okay, to try to preserve a little more space here. 3, negative 7, negative 2, and 8. So we bring down the 3. Negative 1 times 3 is negative 3. So then if I put those together, that's negative 10. Negative 1 times negative 10 is positive 10. Negative 2 and 10 is positive 8. What is negative 1 times 8? Negative 8, and bingo, there's my remainder of 0. So that means, again, if I have my answer box to fill in, I already know what goes in my answer box down here if I'm trying to figure out what x equals. I know that x is already equal to negative 1. I can put a comma because I should expect 2 more of them, right? Well, let's see. What is the remainder? So this is the rest of this. So this is going to be x plus, where do I get plus 1 from here? Remember, it's x minus c, so we change this sign when we write it in this form, okay? So then we have the rest of this stuff, and it's equal to 0. So the rest of it, right, x squared, x, and my constant, right? So 3x squared minus 10x plus 8. So x plus 1, and then here, now this one is going to be a little bit more of a challenge because I have 3 terms with no GCF, and there's a 3 out front. That's bottoms up, right? So I have to transform it into list method. List method is pretty simple, but bottoms up is not so much because you have to transform it first and then transform it back. So I'm going to take the 3 times the 8, and I'm going to come down here in a thought cloud. I'm going to do that over here since I have some space here. All right, this is a terrible board presentation. All right, but I have some empty space over here. So this is going to be x squared minus 10x plus 3 times 8 is 24. So now I have list method. I want the factors of 24 that add to give me 10. I don't worry about the negative right now. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are my factors of 24. Which ones add to give me 10? 4 and 6. So this is going to be x and 4 and x and 6. Now I'll worry about the signs. This says they're the same. I don't mean those 2 signs are the same there. They're not. I mean down here, this and this are going to be the same. And they're going to both read this. When we have this circle, right, we say both, that sign there. So they're both negative. Okay? So both negative. But I'm not done. I'm not done because to finish bottoms up, I've got to go back. And since I multiplied by this 3, I've got to do what? Divide by 3. So I've got to divide this by 3 and this by 3. So 4 over 3 won't simplify. That's where the bottom comes up. So that's going to be what? 3x minus 4, and then here 6 over 3 becomes a 2, so then that's x minus 2. And now I can set each one of these equal. In the first one, look, I already have this. I already know this is there, the x plus 1 one. So I can subtract 1 if I want to. I already have it. That's this answer right here, right? Those are the same. I already know that. And that's when I found my 0, right? And then here I'm going to add 4 to both sides, and that gives me 3x equals to 4. Divide both sides by 3, and I get x equals 4/3. And I'm glad I did it this way and didn't have to use 4/3 in synthetic division. And then here add 2, and I get what? X equals 2. So negative 1, 4/3, and 2 are my zeros for that function or polynomial. So then this is the last one I'm doing. Notice this is a 4th power, so this is going to require a little bit more oomph, a little bit more work here, right? A little more. Put you back into it a little bit more here, okay? Heavy lifting. So it's the same deal, though. My a sub n here is still times the first, and my a sub 0 is still the last number here, right? So my absolute a sub 0 is 8, and my absolute a sub n is 1. Even if those were negatives, I would just deal with the positives, right? So this is 1 and 8. We've seen this before, 2 and 4, and then just 1 for that one. So plus or minus 1, 2, 4, and 8 over 1. So plus or minus 1 over 1, 2 over 1, 4 over 1, and 8 over 1. So here, I only have 8 possible answers. 1, negative 1. 2, negative 2. 4, negative 4, and 8, negative 8. And I expect to find how many? Or I shouldn't say expect. I can find at most 4. I can't find any more than 4. But if I can find 4 out of 8, then I expect to find 1 every 2 times I do it. So hopefully, I find 1 in the first 2 tries. However, it's called expected value because it doesn't always work as expected. Okay? Since there's 8 possibilities, I could try the 4 that don't work first if 4 work. All right? So at most 4 work. So let's go through this. Set it equal to 0. And we're going to start synthetic division here. Okay? So this is going to be, let's start with 1 on the porch. We're going to have 1, that's x to the 4th. Minus 4 is x to the 3rd. Minus 3 is x squared. 10 is x, and 8. So this time we have 5 numbers across here, but that's because we go x to the 4th, 3rd, 2nd, 1st, and then my constant after that. So we drop down the 1. 1 times 1 is 1. Negative 4 and 1 is negative 3. That's negative 3, and that's negative 6. 1 times negative 6, that's 4. 1 times 4 is 4, and that ain't 0, right? So 1 does not work. Yay for us. We did all that, and 1 doesn't work. So now I'm going to try negative 1 and hope that works. So 1, negative 4. This part's the same. Everything in the setup's the same, except instead of 1 on my porch, I got negative 1 on my porch. Drop this 1 down. Negative 1 times 1, negative 1. Negative 4 minus 1, negative 5. Negative 1 times negative 5 is positive 5. Then we, again, right, we're adding these. That's why I'm going through it quickly. We're adding, not changing the sign. So negative 3 and 5 is actually a 2. When you add the 5, you're not changing it. And then when you combine those terms, they're different signs. You subtract to keep the sign larger. Negative 1 times 2 is negative 2. 10 minus 2 is 8. Negative 1 times 8 is negative 8. And bingo, we got 1. That's great. Great, great, great. All right, so here, I already know if I have my little x equals box down here, right? I already know that one of my answers is negative 1. Okay? And then I know that I have x plus 1 because it's the opposite sign. And now, if this was x to the... See, if this was x to the 4th, this is x to the 3rd, right? It only goes down 1 power. So x to the 3rd minus 5x squared plus 2x plus 8. And that also equals 0. But wait a minute. This is 4 terms, x to the 3rd. And if I look at that, I don't see any way to group it. If you can find a way to group it, that's great. But on this one, I don't see any way to group it. So guess what? Now I've got to work this part just like I worked the 2 problems previously. The only difference is I already have my list. No need to go through my list again. Just don't try 1. You know 1 doesn't work. I already got negative 1. Negative 1 could work more than once, but rather than do that, just go to the next number. Now, the problem you come into is if negative 1 is all 4 of them, then, well, you should have tried it again. Okay? But 1 doesn't work. We already know it doesn't work. It's not going to work on this one. So, let's come over here and look. Let's see. This is going to be, let's try 2 on my porch. And we're going to say 1, negative 5, 2, and 8. We drop the 1 down. 2 times 1 is 2. Negative 5 and 2 is negative 3. 2 times negative 3 is negative 6. That's negative 4, isn't it? 2 times negative 4, look at that. That's glorious. So now we already have the x plus 1 out front, right? We have the x plus 1 out front. Don't forget that's there. And then for the rest of it here, we have x minus 2, right? This 2 comes down here and it changes signs, right? So, and then we're left with the rest of it equals 0. This is the rest of it that goes here. So now if we started with x to the 3rd, this is x squared, right? So it's 1x squared, then it's minus 3x, and then minus 4. And hopefully this can be factored. It's x squared now. But everything you've ever learned about x squared is on the table. Quadratic formula, complete the square, difference, not difference of squares, square root properties is what I'm trying to say. All those things are there, right, on the table. This is list method. It's factors, okay? So I'm going to leave my x plus 1 out here. Oh, and by the way, I already know what as well. If 2 is on the porch, 2 is one of my answers here, right? And so this is x minus, that's where that one comes from. And then if it factors any further, it's going to be x and still be 0, right? So the factors of 4 that subtract to give me 3, okay? So 1 and 4 or 2 and 2. 4 minus 1, right? 1 and 4. The signs are different. I know those are the same. That's not what I'm talking about. These down here are different. The bigger number gets a minus. Which one's bigger? The 4. 4 gets a minus, 1 gets a plus. All right? Now I'm ready to set each one of these things equal to 0 and solve, which I already know the first two. This is just doubling up your work here, which you don't need to do. But in case you didn't write them down, then this is how you would go back and find them. But once you find them, you know they're there. So here we subtract 1. We already know that. That's that one right there, right? And then here we're going to add 2. And we already know that one because we used synthetic division. We got the 0. That's that one. And then here we're going to subtract 1. And we get x. Wait a minute. Negative 1. And look, you don't write negative 1 again. You already have it right here. So don't write it again. It just means it occurs more than once. Its multiplicity would be 2. It occurs twice. Okay? We weren't asked to factor this, or we would have written that squared maybe. So this is going to be x equals 4. So even though I had a fourth power, I only had three distinct or different zeros. Just one of them occurred more than once, the negative 1. But just don't list it more than once in your answers. All right?